Welcome to Khetz Tutorials, and in this video I'll be doing yet another example, and this is related to tree diagrams. If you haven't watched the first video, I'll link that top right and you can just check that out. So let's get right into the problem. It says Samantha has just obtained a driver's license. She wants to buy a car and has the following options. Now remember that when we talk about tree diagrams, we're talking about consecutive events. So something will happen here and we have some other options, and this is a good example of where we have quite a few options to deal with. So if you look at the options, the car can be a VW Polo or it can be a Toyota Yaris. Then after that, so let's start. We can also start, I think, yeah, it's perfectly fine to start the example because the first thing over here, we are required to draw the diagram. So we might just start drawing as we read the statement. So here are the options that we have. So to start with, we have to decide whether we are going for a Polo or Yaris. But a Polo can be a sedan or a hatchback. So it can be a sedan. Let's just use S and HB for hatchback. And the same applies to the Yaris. It can be a sedan, it can be a hatchback. And after choosing the type of car, then we have to choose the color. And the options that we have are white, black, or red. So a sedan can be white, black, or red. A hatchback can be white, black, or red. A Yaris sedan can be white, red, black. Is it black? Yes, black or red. And a Yaris hatchback can also be white, black, or red. So this is the tree diagram which shows all the options. Let's say you pick a Polo, it can be a sedan. Let's say you pick a Polo, it can be a hatchback. And within these options, we have other options to look for, and that is how the tree progresses in that direction. To start off with picking a car manufacturer or the type of car, and within that you have a sedan, you have a hatchback, and within that you have colors to choose from. And once again, just to complete this, we have to write our probabilities, and we aren't told anything about the distribution of the probabilities. So we can always assume that they are evenly distributed, which means we can have 1 over n, where n is the number of options. So first of all, we have two options, a Polo or Yaris. So 1 over n will be 1 over 2 for the probabilities. Then we can choose a sedan or a hatchback, and that is two options again. So we have 1 over n again, which is 1 over 2. The same applies over there. Now finally we have three options, white, black, or red, and the n, which is the number of options, would be 3, and that is the value of all these probabilities. Just that I don't have much space to put in all of the 1 over 3s, but that is what you have to do. Then finally you have to write down all your options, starting, let's just say P for Polo and Y for Yaris. So you have PSW, PSB, PSR, and that is all of these options. Then after that you have PHBW, PHBB, PHBR. Then we're now done with everything that has to do with the Polo. So we expect to have 1, 2, 3, 4, 5, 6 options. And that would be 1, 2, 3, 4, 5, 6. So we have all of them. Now we move on to the Yaris, and we have YSW, YSB, YSR, YHBW, YHBB, YHBR. So you have to write all of these options once again. Don't forget to write that. I think it counts 4 marks. And just so you understand that we can fall in any of these options, or we can go along any of these branches, because we don't know if we are randomly picking. And the next question actually does talk about randomly picking. And it says, it is equally likely that Samantha may choose any model, any type of car, or any color. So that is why we basically use the 1 over n, because everything is equally likely. And now she chooses a car at random, so we don't know which option we're going to fall under. So when we write all of them, we're saying these are all the possibilities, and we can't just write one of the possibilities if we're picking it at random. So what is the probability that Samantha will choose a red car? Okay, so which of these are the red cars? So we have to add everything that has R in it, because nothing else was specified. We aren't talking about a Polo which is red or a Polo which is a hatchback, with nothing like that. So we're only focusing on this information that we're given. The only requirement is that the car has to be red. So what is the probability of having a red car? So we have to add the probabilities of everything that has R in it. And if you check, we have 1, 2, 3, 4 options for that. And those 4 options, you can see that all the branches basically have the same values for probabilities. So to write our answer in compact form, we can just say we're going along the path. And remember that when you go along the path, you basically multiply the probabilities along the branch. And to show that with one branch, if it were a Polo sedan and it's red, then you basically multiply 1 over 2, 1 over 2, and 1 over 3. So now if you look at the whole diagram, you basically have the same values everywhere. So you can just write it in compact form and say we have 4 cases where we're going to do the same multiplication. And those 4 cases actually show where we have red cards. And the multiplication is basically 1 over 2 multiplied by 1 over 2, and then finally multiplied by 1 over 3. So picking a Polo Yaris, then picking the hatchback or sedan, and finally picking a color should give you the final answer of 1 over 3, and that is your answer. You can write it as this as well. That should be fine. And that is how you basically do this. You just go along the path and multiply everything that you find along the path. And this is for events which satisfy the condition which you're given in the question. So let's look at the next condition. It says, what is the probability that, okay, so I see that you asked to write this in 3 decimal places. You can just leave it as 0.333. Now in the next question, it says, what is the probability that you choose a VW hatchback? So there are 2 conditions here. We know that it has to be a Polo and it has to be a hatchback. So we can't just choose any hatchback and we can't just choose any type of car. It's specifically stated that we're looking for a Polo and it has to be a hatchback. But please note that nothing was said about the color. So nothing was said about the color, and you can then just pick the options that have these 2. So as long as these 2 are in check, then everything else doesn't matter. So we just have to look at the ones that have PHB. So PHB, 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 there they are. And those are 3 options, right? So as long as it's a Polo and a hatchback, it can be any color. So we have to add all of them so that we have the sum or the total probability that we're looking for. And since we have 3 options, and in those 3 options, once again, we're just going to do the same multiplication. And I just go through it just so we are on the same page once again. And if you do this, this should cancel with that. And finally, you just have 1 over 2 multiplied by 1 over 2. And the answer to that should be 0.25. That is your answer. And just to show one of these multiplications, you have a Polo, which has 1 over 2. You have a hatchback, which has 1 over 2. And you have white, for example, which has 1 over 3. And so if you want to write it out in its full form, then this is what you basically do. You'd add that option you'd add the other option, and I just basically put it in compact form by just multiplying 3 with everything to show that you're basically doing this 3 times, because a polo, which is a hatchback, appears 3 times. So just always make sure that the probabilities which you add together basically satisfy the given conditions. In the previous question, we just had to satisfy this condition that says the car is red. So you add everything which has R in it, everything. And in the second one, it was a bit more specific. They did say that it has to be a polo and it has to be a hatchback. So everything that is a polo and which has this property, which is being a hatchback, has to be included. But nothing was said about the color. So we add all of the different colors as long as we have a polo and a hatchback. So what you have to notice is how you draw your diagram, how you compute the probabilities, and how you actually get your answers from the tree. So that is all with regards to this example. One other thing that I want to mention is you can have questions where having an option actually decreases the number of options. So let's say you have cups and you had to pick a cup. So if this white cup and this blue cup, and then let's say we have a green cup. Now, if you pick a white cup and you're told that it's not replaced, then in the next pick, you basically only have blue and green. If you pick a blue cup, then in the next pick, you only have white and green. If you pick a green cup in the next pick, then you only have white and blue. So you should check your situations. If you ever have something that has to do with replacement, then just look out for that. If you're told that options are taken or an event basically happens and we are not replacing, then you do expect that your options should be smaller. And take note of the path. Now, if you take a white, then a blue, then the only option there will be green. If you take a white and a green, the only option there will be blue. If you had 3 iterations of this thing. If you only have 2 iterations, then you only have 1 cup less in the next phase. But now, if you go all the way, you only have 1 option to deal with in the last phase. So there might be some events, there might be some cases where we talk about replacement, and just take note, if you do replace, then the number of possibilities remains the same because we're replacing. I took white and I put it back, so I still have it there. But if I don't replace, then the options are actually less in the next iteration. So those are the things that I had to talk about with regards to tree diagrams, and I hope it was of value to you. I will be moving on to another topic in the next video. If you like this video, just give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.